My lesson is, do you speak the language? Do you sometimes thought that somebody talks just like engineer, doctor, lawyer, or a teacher? How often do you think different? How often do you brainstorm? How often do you search for problem solutions in new environments? To think different is easier than said. Different professions are trained during their schooling to think differently. They use different methods of problem solving. Their training and experience influence the way they think. If we don't understand that other people think differently, we don't have a chance to understand them and to communicate to each other. Let's talk about how doctors think. Medical careers require a special ability of problem solving, synthesis of a lot of information, great endurance, and genuine commitment to their job and research. Thinking like a doctor include piecing facts and observations together with the patient's story. 90% of diagnoses are made on the patient's history alone. Becoming a good listener and putting together what you hear is the key to making most diagnoses. Doctors are trained to think about differentials and categories. Patients presenting signs and symptoms are preceded, then historical information is used to determine the most common diagnoses associated with a group of symptoms, signs, tests, and we call that differential diagnosis. More complicated tests are done based on the most common diagnoses like lab tests, biopsies, pathological findings, molecular findings, and then treatment is often based on the outcomes of these whole tests. This is a categorical approach to problem solving. Doctor tries to determine what category the patient belongs in, and the treatment is based on the assigned category. This is a very efficient system when the patient has a problem that has been encountered before, but very inefficient if we don't see this category of symptom, signs, test earlier. Programmers would call this searching a known set, fastest way to find the solution if the solution is in the set, and slowest if the solution is not, as all possibilities have to be excluded before determining that the answer isn't there. How is to think like an engineer? From my personal experience, and I consult the literature, engineers and doctors model systems and solve problems differently. It takes years of study and practical experience to learn the ways each field views and navigates. This differs from the way untrained, inexperienced people think about problems and solutions. What do engineers do? How engineers think? How do they approach problems? What goes in on the mind of an engineer when he or she is doing engineering? Engineers make things that work or make things that work better. Literature identifies 6 engineering habits of mind, which taken together describe the ways engineers think and act. First of all, systems thinking, adapting, problem finding, creative problem solving, visualizing, improving. Systems thinking means seeing whole systems and parts and how they connect, recognizing interdependencies, synthesizing. Problem finding means clarifying needs, checking existing solutions, investigating contexts, verifying, regarded as a sophisticated engineering habits of mind and more likely to be exercised by experienced engineers or by learners after they had successfully built up a base of approaches to problem solving based on given problems. Visualizing means move from abstract to concrete, manipulating materials, mental rehearsal or physical space and practical design solutions. Improving means relentlessly trying to make things better by experimenting, designing, drafting, guessing, making hypotheses, thought experimenting. Creative problem solving means applying techniques from other traditions, generating ideas and solutions with others, and rigorous criticizing, which see engineering as a team sport. Adapting means testing, analyzing, reflecting, rethinking, changing physically and mentally. This is all the systems of habits of mind, including learning habits of mind, engineering habits of mind, and core engineering mind. That means making things that work and making things work better. How it looks like how it looks when we compare doctors and engineers thinking. Doctors know how they think about patients, diagnosis and treatment in practice. Doctor knows the common errors in reasoning lay people make about disease. They come to us with self-diagnose and treatment from the internet. Engineers know the analogous things about their own field, and they always have an idea for solving problem and making things better. Neither doctors nor engineers understand how their way of thinking differs from the others. Doctor thinks of the engineer as a smart person who can make stuff better. The engineer figures medicine must work pretty much like engineering, like applied science, systematic measurement, testing, debugging. This is why every first-time medical software entrepreneur want to make diagnosis applications like, you doctors only collect the data, my miracle program will find the diagnosis. Engineers don't understand the non-specificity of most symptoms, even in combination, and how and why we must rule out common diagnoses before considering rare ones. They don't understand the skepticism about screening tests and false positive, false negative results. Engineers assume that once we have enough sensors, blueprints, and service manuals, fixing and improving humans will be the same as for engineered systems. It won't. Humans and software machines have ridiculous differences which will require a new paradigm. Difference between engineering and medicine is we create engineered systems, and so we understand how they work. There is no machine or software system that have the complexity as a human body. Event-driven nature and constantly changing underlying data, updating versions of libraries and standards make modern software pretty complex. Human can't be debugged this way. You can't stop the circulatory system and see what happens. You can't remove a patient liver and put in a kidney and rerun your unit tests. It is possible to simplify software temporarily as part of the debugging process, and to isolate a bit of code and test it with artificial inputs of your own construction. Human patient is always a complete complex system. One of the main goals of medicine is longevity, and the standard debugging process can't optimize that. We can't predict how long our patient can live. Doctors have their medical speak, and engineers have their own jargon. That's the reason how important information could get lost in translation when two groups of people don't speak the same language. For example, when we talk about chest sound, doctors said normal chest sound. We have exact terms, normal chest sound, crackle, wheezing, and when engineer talks about chest sound, they will talk about intensity, about frequency of that sound. We need healthcare professionals who are experts in technology and who can translate to engineers and others the needs of patients. In medical school, nothing was designed to help developing complementary skills. Every doctor now uses advanced technology during their daily work, but only a few have the technical vocabulary or training to help develop it. I compare other professions like architects versus engineering. Architects have spacious way of thinking. They are creative visions comparing to engineers. Engineers taught in school to solve problems using their chosen functional specialty such as structural engineering. While both architects and engineers might be involved in the design and construction of a building, they tend to focus on a different aspect of the job. Architects concentrate on the artistic creativity of design. Engineers focus on the scientific innovations that will bring those designs to life. Mathematician versus engineers. Mathematicians work with complex theories and mathematical data, and engineers use their knowledge to create plans for products or structures and must ensure their creations comply with regulations so they will function as intended and be safe. Physicist versus engineer. Physicists try to know why and how something happened. An engineer takes those principles and uses them to design, build, and produce things we often take for granted. In conclusion, a better understanding of the problem-solving methods of others can improve communication. lot of communication problems could be solved by just putting everyone in the same room together. We need a new approach at the engineering-medicine interface that teaches engineers and healthcare professionals to work together in teams. Finding ways to reduce literature disciplinary separation between engineering and medicine and other professions is a key for innovation. The technology revolution influenced the healthcare industry, and if used correctly, technology such as artificial intelligence, robotics, machine learning, we will reduce costs, extend the reach of healthcare services, and save lives. Experts are needed who are well trained in both technology and healthcare. We can call them healthcare systems engineers. Engineers are trained to be problem solvers, and medicine is full of problems. We can enhance insights for new therapies, better medicines, and innovative medical devices by bringing creative minds together from across the professions. Thank you for your kind attention.